All right, number 2 here. The shark. Not just a shark, a type of shark, the shark. And you know which one I'm talking about. The shark can accelerate to a speed of 32 kilometers per hour in a few seconds. Assume that it takes a shark 1.5 seconds to accelerate uniformly from 2.8 kilometers per hour to 32 kilometers per hour. What is the magnitude of the shark's acceleration? So, what do I know here? I know I have a time. Oh, my pen's starting to run out. I have a time, 1.5 seconds. I have an initial velocity, right? It accelerates from. So I have an initial velocity. And then I have a final velocity, right? Top speed. Final velocity, 32 kilometers per hour. Sorry about my bad penmanship there. So one thing I want to notice, I want you to notice, the question is just asking for the magnitude of the acceleration. So when you actually get to your answer, you actually don't need to have the direction. Understand that? Now, accelerations do have directions. That's true. However, the question isn't asking for that, is it? It says, what is the magnitude specifically? So the customer is always right. Make sure you're doing what the question is asking you to do. Because even if you do something that's cool and makes sense, if it's not what the question is asking you for, I can't give you any points. All right, so the equation that I'm going to choose, let's pull, if I can. Let's pull my equations back up. And again, I'm modeling for you how I want you to go about this, guys. You don't have to have these memorized yet. Open up your textbook, open up your notes, open up that worksheet that we used the other day. Have these in front of you so you can get in the habit of choosing which equation works for your situation, right? Based on what you've been given. So here, I have a time, I have an initial velocity, and I have a final velocity, and I'm being asked to calculate acceleration. So I'm going to need an equation that has all of those things. Okay, it needs all of those things. Which of the 5, usual suspects, the usual variables, do I not have here? Have you guys figured that out? Which one do I not have? What's that? Yes, delta x, right? I do not have a change in position, right? I don't have a displacement. And so I'm going to disqualify all of the options that have a delta x in it. So this actually gets pretty simple. There's a delta x, don't use it. Here's a delta x, don't want to use it. Here's a delta x, don't want to use it. So what's probably my best bet? This guy right here. This guy right here. So I'm going to rearrange that. Let's get back to the camera. I'm going to rearrange that so that I'm solving for acceleration. So I have my VF minus VI divided by delta T, okay? And yes, I do get to expect you to be able to algebraically rearrange equations so far, right? You're all in integrated 3 or above. You guys got this. So once you're to this point, I can just plug and chug. So I'm going to go, wait, which one am I starting with? Oh yeah, sorry. So my final velocity is 32 kilometers per hour. I'm going to subtract 2.8 kilometers per hour. Now, what I'm going to do here, which is the thing I forgot to do last time, right, is I'm going to get my conversions out so that I can report this in meters per second, just because that's a very physicsy thing to do. Remember, in order to cancel out these hours, I need hour on the top. And I'm going to go into per second, so I'm going to have 3,600 seconds on the bottom. And I want to convert out of kilometers and into meters. So every 1 kilometer has 10 to the third, or 1,000 meters. Hopefully that's big enough for you guys to see. And that will make my units become meters per second. Now, in the prompt, in the question, is there anything that asks you to specifically report it in meters per second? No. So if you reported a kilometers per hour, as long as it was the correct number, would you be fine? Yes. Okay. I just want to be on record that you guys have seen this conversion style, so that anytime you see it anywhere else, you're familiar with it. Don't forget to divide by my time, which is, 1.5 seconds. And then we're in a situation where we can plug and chug. Now, when you guys are on a test and you're trying to get this and it's really going to affect your grade, I do suggest when you guys are doing your plug and chug, I suggest that you do it piece by piece, that you break it down. For example, I might just plug in my calculator, 32 minus 2.8. And then I would actually write everything down again with, what is that? I just said it. I forgot. 29.2. I would actually write that down and then write everything out again, right? Just to help myself make sure I don't make any calculator errors. Now, if you have a big old TI 83 or 84 or 85 or 1,000 or whatever, as long as you place your parentheses correctly, you'll be fine, right? That'll take care of it. But I do suggest maybe breaking it down into a smaller calculation. But as long as you do your calculator work appropriately, this is going to come out to be, let's see, I want 2 sig figs, 2 sig figs, 3 sig figs. How many should my answer have? 2. So I'm going to report this as 5.4 meters per second squared. And again, the question is only asking me for a magnitude, so I do not have to include a direction.